So to start, I'll open with a demo. While watching this, you may notice a small inconsistency. I will go over these limitations of the Arduino right after and then explain my process along with my submission. So the Arduino serial pins are 0 for receive and 1 for transmit respectively. However, while managing to successfully transmit data back and forth for UART, I came across some limitations of the way these serial pins are created on the Arduino. So internally, the Arduino's USB sends the data serially, and the Arduino Uno only has 2 serial pins. So internally, when you send data through the USB in the serial monitor, you're actually receiving that data internally on the receive pin for the Arduino. However, when we have a receive pin wired to our FPGA board, it ends up shorting out the data and it doesn't end up saving in the Arduino serial buffer. So we have a workaround. Instead of just purely receiving from the USB, I have to unplug the receive pin temporarily so the buffer can then capture the data. Then once I'm done receiving the data from the serial monitor, I can plug the receive pin back in so it's ready to receive data from the FPGA board. Another thing to note is that anytime you call a display function in the serial monitor, you are technically writing that data along the transmit pin. So if I receive a 5 from the FPGA board and I want to display that on my serial monitor so I could see what I received, I end up writing that 5 straight back down the transmit pin. This means I can never fully empty the buffer on my FPGA board, and the only way to do a clean data input test after that is to manually wipe the buffer on the FPGA board, so reset the board, and then send fresh data again, making sure to unplug my receive pin again. Despite these limitations, I would still like to explain my process. So first I went to the constraint file for lab 10, and I enabled 2 pins on PMOD header JB, it's the one on the top right. I then enabled pin A14 as my receive and A15 as my transmit. And then before connecting the Basys3 to the Arduino, I had an issue where the Basys3 can only handle 3.3 volt logic and the Arduino's 5 volt logic. To resolve this problem, I purchased a SparkFun bidirectional logic converter, which allows me to step down the 5 volt to 3 and increase 3 to 5. After resolving this problem, I just had to write a small Arduino code to read in from the Arduino serial buffer and then to transmit out over the pin. I did try to rectify the issues with the serial buffer by using the software serial library, which allows you to simulate the serial pins on any other digital write pins. However, the issue was that if I did simulate on these, I had no issue sending data back and forth, but I could no longer take input data from the serial monitor. This is because the serial monitor is only readable through receive pin 0, which makes it impossible to simulate this full thing using the serial monitor. The only other workaround I could imagine would be either using an Arduino Mega, which has 3 pairs of serial ports, which could allow you to have a dedicated serial for the USB input, while another 2 are dedicated for data transfer, or attempting to display your data on the Arduino externally and inputting it externally using a combination of switches and or buttons and a 7-segment display. Regardless of the difficulties I did have with this project, I found it a lot of fun, and I'm kind of glad I put in the effort to learn most of this.